Hi guys, so in this video we're going to learn how to read a micrometer and a Vernier caliper. I know if you're thinking, I don't have one in my hand, how's it going to help? But in your exam, they don't give you one, they give you pictures. You have to be able to read it, okay? So we're going to go over how do we read them and why would you use them in your exams. So micrometer. Micrometer, when no one use, we're measuring the diameter of wires, okay? So any of your required practicals, you've probably had one where you have a diameter of a wire, or you have a wire, sorry, and you're trying to figure out its diameter, right? Because remember, a wire has got a cross-sectional area, right? We imagine it kind of like a cylindrical in shape. So we know that they have a diameter. And the way we measure that diameter of the wire is we take our micrometer, you put the wire between the two jaws of micrometer, so measure its what diameter is. So again, we put the wire between our two jaws of micrometer, and we can measure what its diameter is. Key things, and this question comes up quite a lot, how should you do this? And the way they should do it is that you should do it at multiple locations and orientations. Okay, so the reason we do it at multiple locations is I want to make sure that all the way along here, that wire is uniform, right? It's uniform in diameter. And I also want to do it at multiple orientations, right? At different, say this is my wire. I'm not going to just put the micrometer here, here, and here, right? I'm going to make sure that I use different orientations here, and then here, and then here, because I want to make sure that it's not just uniform in this dimension, but it's uniform in all of the dimensions. Okay, so multiple locations and orientations, okay? And normally when you're doing this experiment at school, you should take the diameter reading at least 3 different times. So you get 3 different values for the diameter, and then you just take an average or a mean of them to find out what your diameter of your wire is. Other ways that we should do it, okay? So let's imagine the jaws are open, okay? So micrometer is open, and there's my wire between it. What I'm going to do is I'm going to close the jaws using the thimble. So you use like a little thimble here, and you basically just twist it around to get the jaw, to get the jaws to close. So the jaws will close, 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 close. But as soon as I get really close to the wire, I'm not going to use the thimble anymore. I'm going to close the last little bit with this thing called a ratchet. And the ratchet is like a little bit right in the end. And it just controls it easier, closing that gap, because it does it much slower. And the reason you want to make sure you close it much slower towards the end is I want to make sure that I don't end up compressing the wire. So again, if my wire is between my micrometer, I don't want to make sure that I'm squeezing that wire, because then I'm going to end up deforming it or changing its shape and get a different result for my diameter. Okay, so again, we make sure that you close it first with a thimble, and then second, you close the last gap using that ratchet, okay, because it gives you much more control. Okay, you can do it much more slower to make sure that you don't change the value of your diameter. Other things need to remember when you use it is when the wire is not inside it, so we should take the wire out, and we should make sure that what we do is we close the jaws first. Again, do it quickly with a thimble to get them close together. Then that last little bit we're going to close with the ratchet to close that gap, and we're going to check to make sure that it says 0, okay? So we call that checking to make sure it says 0. We call it calibrating. Okay, so for example, if you think about your scales or your balance, if I want to weigh myself, so much mass I have, I'm not going to step on the scales when they already say 10, right? I'm going to tap the scales with my foot to make sure it says 0, and then I'm going to get on the scales to see what I weigh, okay, or what my mass is. So same thing here, I'm not going to start reading if it doesn't say 0. So I'm going to calibrate my equipment, make sure it says 0. If it doesn't say 0, just get a different micrometer, or you can calibrate it yourself. So you just edit it until it gets 0. But easiest answer in test is just check that it reads 0 by closing it, make sure it says 0, calibrate your equipment, and then just get a different micrometer. Okay, so how do we read it? So let's say this micrometer, I've got my wire again inside it. I've closed the last little gap using my ratchet to find out what the diameter of that wire is. And this is what it says my diameter. So hopefully you can see the big number here is 0. So this is how it's going to look in your exam. What you want to do with your pencil in your exam is mark some numbers on it. So there's 0, there's 1, 2, 3, 4. Okay, so clearly it's something bigger than 4. Now look at these little lines between it. If it's between 0 and 1, that must be 0.5. There's 1.5, 2.5, 3.5. Some people, when they see this here, they think, does that count as a line or not? And yes, it does, because if you look at it, clearly we're bigger than 4 here. We haven't quite reached 5, but we're definitely not really small, right? We're definitely bigger than 4.5. So I can see that little line there. It is something that's bigger than 4.5, right? Clearly it's not going to be 4.2 because it's quite far away from that 4. So it's bigger than 4.5, but we don't see the number 5, so it's definitely less than the number 5. So we're between 4.5 and 5. That's when we look at this section then. So there's number 35, there's 36, 37, 38. Okay, so it's bigger than 4.5, it's smaller than 5, and I just add on the 38. So bigger than 4.5, smaller than 5, I'm going to add on 0.38. So 5, 6, 7, 8, we're going to get a final answer of 4.88 millimeters. Okay, so 4.88 millimeters. Bigger than 4.5, less than 5, we add on the reading there. So again, let's look at another example. There's 0, so there's 1, 2, 3, 4, 5, 6, 7. There's 0.5, 1.5, 2.5, 3.5, 4.5, 5.5, 6.5. Now clearly here, even though we may be debating, do we use it or not, you can clearly see this is much closer to 7. So this time it's something that's going to be less than 7.5, right? Because it's really close to the 7. Whereas here we need to include that line because 1, you can see it. But yes, you might think, I barely see it. Should I include it or not? The answer is still yes, because we can clearly see that it's much bigger than 4, whereas here we're much closer to that 7. So again, we're smaller than 7.5, okay? But we do know that we're bigger than 7 because I can see the number 7. So bigger than 7, but less than 7.5. So we look here, there's my 40. So there's going to be 41. So do you see how this line lines up with the 41? Whereas here, this line lined up with the 38. So because the line lines up with the 41, I add on 0.41. So again, it's bigger than 7, less than 7.5. So it must be 7.41 millimeters. Grand. Okay, so next one then is our vernier calipers. So you might think, when do we use vernier calipers? Vernier calipers, you know, when to use, let's say I've got a ball, okay? So let's imagine we've got a little ball and I want to measure what is the diameter of that ball, okay? So what we do is we just take the ball and we put the ball between these two parts of my vernier caliper. This little bit in here is what we can measure the inner tubing. So let's imagine you had some type of tubing. Oh, I've got a toilet roll here. So let's imagine we have the toilet roll. I could measure the outer diameter using here. You might think, why have toilet roll? It's to rub out the board. So we use the vernier caliper to measure the outer diameter here, and then we can use these bits in the middle to measure what that inner diameter is inside the hole, okay? So we can measure both of those components. Okay, ways that you probably see the vernier caliper being used is when you're doing the double slit experiment. So you know in the double slit experiment, you've got your 2 slits, and we know what happens is I'm going to get light that's going to pass through the gaps. They're going to diffract around the gaps. And there's going to be places where they're going to superimpose. Places where they superimpose where there's 0 path difference and they're exactly in phase. We're going to get our bright spot or our constructive interference, BRIGHT. And then places where they're exactly out of phase or there's a path difference of about half a wavelength, we know we're going to get our dark spots. We're going to get bright spots, dark, 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 bright spots, dark. So that's what we see on our screen. So on our screen, we see those alternating bright and dark fringes. Something I might want to do is I want to measure the gap between those fringes. So what I could do is I take my vernier caliper and I can measure the gap there between those 2 bright fringes. If I'm doing the AQA spec, the letter we use to represent that is W. And if you're doing the OCRA spec, the letter we use to represent that there is X. So it's called the fringe spacing. However, you should know that you're not just going to measure one fringe spacing, right? We know to reduce the percentage uncertainty, we need to measure over multiple values. So what I really should do with my vernier caliper is I should measure from here all the way down to here. So I've got 1, 2, 3, 4, 5 fringe spacings. So I'm going to measure what 5W are, or what 5X are, measure across 5 fringes, and then I'm just going to divide by 5 to find out what the distance is of one fringe. Okay, so remember the reason we measure across multiple things, or if I'm timing pendulums, remember we time over 10 swings, not just one, because we want to lower the percentage uncertainty in our results, right? We always want to measure over as big as value as possible. So again, when recording the fringes, measure as big as value as possible, divide by the number of fringes there was, so we can find out the width of just one fringe. So let's say we're doing that. How do we read it? So hopefully here, if you look here, I see 0. There's 1 centimeter. So clearly this number must be 0.5 centimeters. Okay, so what we do first is we can see where the 0 is. In a vernier caliper, the 0 is where you take your first reading. So that 0 is in here. So clearly I'm bigger than 0.5 centimeters. But they're 0.6 centimeters. So clearly I'm smaller than 0.6 centimeters. So I'm somewhere between 0.5 centimeters and 0.6 centimeters. What we do then is we look at these bottom lines to see which one lines up. So you find a line that matches. So if I look at mine, none of those line up, but here, those two line up perfectly. So it lines up with the number 5. So what I do then is I use that bottom number of 5. So it's bigger than 0.5, smaller than 0.6, so it's going to be 0.55 centimeters. That's the reading on my Vernier scale. Okay, let's look at this one. There's 3, there's 4. So now look where the 0 is. The 0 is in here. Okay, so clearly that tells me there's 3.1, there's 3.2. So it's bigger than 3.1. So this time I'm bigger than 3.1, but I'm smaller than 3.2, right? Because the 0 is between 3.1 and 3.2. Whereas here, the 0 was between 0.5 and 0.6. The 0 is between 3.1 and 3.2. Then I look at these bottom lines to see which one lines up. So I look to see which one of these lines up. And the one that lines up quite nicely is this one here. So there's 0, there's 5, that's 1, that's 2. So 2 is the one that lines up quite nicely, 2 on the bottom scale. So I'm bigger than 3.1, smaller than 3.2, so it ends up being 3.12 centimeters. That's how the 2 adds on. So, grand.